Okay.
That's great.
Do you see my presentation?
Yes.
Amazing. Hello everyone. My name is Avetis Mkrtchian. I'm a student of Czech Technical University in Prague. Today I would like to show you an interactive dashboard for ontology quality monitoring, which was my bachelor thesis. OBO Foundry contributes to standardizing biomedical terminologies, taxonomies, and ontologies. To monitor quality, they produce statistics and reports. However, understanding cross-ontology problems, problems of individual ontology concepts, or other more complex queries, the tools are missing. The goal of this work was to create a solution for dashboards or ontology catalogs and test it on the OBO Foundry dashboard. The OBO Foundry has OBO dashboard based on results of the robot tool, which is a prominent test case for this work. This dashboard checks ontologies for compliance with OBO Foundry principles, providing this information with details of the problems. However, this dashboard provides general information about each ontology and does not provide details about violation reports and quality metrics. In order to get more in-depth information, you have to use a robot, which is not very convenient. Also, this dashboard does not show the evolution of ontology quality in chronological order. Robot tool is a command line tool that runs on Java virtual machine and allows you to generate various statistics and reports on ontology quality. The most suitable commands for us were robot report and robot measure. On the slide, you can see what the outputs of these commands looks like. In short, robot report generates a table with violations based on OBO Foundry rules. Robot measure generates data about the number of classes, axons, and many other things about ontology. The robot tools commands listed on the previous slide have no RDF output, but we wanted to make sure that the data from these commands could be stored in triple store. Therefore, we used data quality vocabulary to describe the metrics so that all our data could be standardized. On the slide, you can see a diagram of part we used from this vocabulary. Also, on this slide, you can see how the output of robot measure could be described by data quality vocabulary. Unlike measurements, finding a suitable grammar for describe violations is challenging. So by experimentation, we try to validate ontologies using Shackle. Shackle is a standard that allows validating RDF data using predefined rules called shapes. The great benefit of Shackle is that after validation, it gives a ready report in RDF format. Since in robot tool, the report is generated based on SPARQL queries, we decided to transform these rules into Shackle rules and have the same result like robot tool command. On this slide, you can see an example of what robot rule looks like in SparkQL, which checks if subjects have a lowercase definition. On the right side, you can see what the rule looks like in Shackle. So-called node shape is created where the target classes and objects are specified. Then for each property, you can specify the path, pattern, and violation level. However, not all rules have been transformed in this way. Shackle makes it possible to insert a whole SparkQL query into the shape, but not all rules could be described as you see on the slide. That's why some queries have a robust SparkQL query in them. We try to leave as many Shackle shapes as possible without SparkQL queries in order to increase the speed of report generation. Versions in ontologies is very interesting topic for discussion. Ontologies are standardized and have special attributes such as OVL version or version info, but problem is that not all ontologies fill them in, and if they do, they are not consistent with the others. Thus, the version information has to be consolidated. There are tools to track. There are no tools to track versions of ontologies in chronological order. My goal was to implement a way to track the number of violations in each version of the ontology, or compare, for example, how many classes the ontology has grown by. To solve this problem, the interactive dashboard framework works in update mode. With each update, the framework performs a check to determine if the ontology contains a date stamp attribute. If such attribute is absent, the framework assigns its own version to the ontology data, which is date of update. This approach eliminates the reliance on inconsistent versioning practices and ensures ability to track changes over time. For a quick version check, I used the ontology version extractor created by my supervisor. Let's talk a bit about architecture. The interactive dashboard framework is designed to deliver dynamic dashboards over a set of ontologies that can change over time. The central component of the architecture is robot, which provides ability to generate metrics and violation reports for the ontologies. However, the output generated by a report is available in various formats, excluding RDF. To handle RDF data, the RDF4J, PageGena libraries are used. The ontological data is stored in the GraphDB database, which communicates with the aforementioned libraries via API for the front end. The existing dashboard solution, Kibana, is used. Kibana allows visualization, exploration, and analysis of data from the Elasticsearch engine. However, Elasticsearch does not support RDF data. RDF indexer is introduced as intermediary between Elasticsearch and GraphDB. The RDF indexer facilitates the integration of RDF data into Elasticsearch, enabling querying and visualization with the Kibana frontend. In order to configure the dashboard using the interactive dashboard framework, you need only do 3 steps. The first is to create a SPARQL query suitable for you using RDF indexer. The second is to start indexing data from GraphDB to Kibana using RDF indexer. And the third step is to visualize the indexed data in Kibana. On this slide, you can see how the user interface of the RDF indexer looks like. Everything is quite simple. As I said, it is enough to enter the endpoint, select the type of query, and write the SPARQL query itself. I said the most minimal requirements for indexing, but in fact there are quite a few other more advanced parameters for indexing. After indexing the data, they will automatically appear in Kibana, and all that remains is to just select the appropriate visualizations for the data and save it. Our OBO dashboard contains a navigation bar which contains 3 dashboard sections. Dashboard for one ontology, for specific ontologies, and for all ontologies. The idea was to make a section all ontologies in order to provide general information about all ontologies. Single ontology, so that the user can just select one ontology and get data about it. Specific ontologies is rather so that the user can select several ontologies and compare them, for example, by the number of violations. On this slide, you can see what the general information about the number of ontologies looks like, as well as their list with names and repositories. This screenshot is from the single ontology section. As you can see, the user can select the ontology itself from the list, as well as its version. Further, the user below sees information about the number of warnings and errors that this ontology has. Scrolling below, the user can find a table with metrics for the selected ontology, these metrics are identical to those generated by the robot tool. The user can also find a table with violations that demonstrates where the violation is and its value. Also, the name of the rule is clickable and leads to a website where this rule is described in detail. In Kibana, the user can use the Kibana query language, with which user can filter the data. For example, as shown on the slide, find only violations of the warning level. On this slide shows a graph that is located in the all ontology sections. It shows the top ontologies by violations. Evaluation. We got feedback from the OBO community through questionnaire and discussion format. The questionnaire results revealed the most of the comments were focused on the dashboard's user interface rather than the data it contains. The primary drawback highlighted by participants was the height of the dashboard box, which required constant scrolling down to access the most relevant information. This was caused by the navigation bar taking up a large percentage of the available area. Additionally, Kibana has its own user interface elements like data filtering fields that further reduce the available space for the dashboard content. The separation of sections in the navigation panel also raised doubts. Most participants would like to see the all ontologies and specific ontologies sections in one. Almost all participants had problems with filtering data from the first time. This is due to the fact that filtering in Kibana is quite specific and takes a little time to sort it out. As with all other things, science, Kibana is a bit technical user interface. So for the positive qualities of the dashboard, the main feature that the community appreciated was the version of ontologies with the possibility of tracking the number of violations in chronological order. One participant was surprised at how we approached the method of generating a violation report by transforming robot rules into shackle syntax, as well as the description of metrics generated by robot using data quality vocabulary. Another useful thing of this dashboard also for the participants was for links to the robot rules website page and to the repositories of ontologies. The presented solution shows in a flexible and configurable way to configure interactive dashboard over ontologies stored in triple store, while still providing useful outputs to the domain experts, as our experiment showed. Of course, we would like to achieve integration with OBO dashboard. In future, we would like to address several research directions. First, making indexing of large ontologies more efficient and robust. Also incorporating other types of ontology metrics and quality control rules that those provided by robot tool. Last, creating a set of predefined quality control widgets for some default dashboard ready to provide basic quality related information about any OL ontology. That's all I have. Thank you for your attention.